All right, before we actually write out the derivative of a natural log, actually the derivative of the natural log and exponential is really easy. All right, so it looks kind of hard when you're looking at it, but it's actually not. But before we do, I want to talk about the top half real quick as a reminder from Algebra 2 and pre-cal last year. So here we go. What is a natural log of e?
1.
Thank you, 1. What's a natural log of 1?
E. 0.
0, thank you. For a natural log of a combination that's got a multiplication, we separate them by a plus sign. So natural log of a plus natural log of b. And then natural log of a to the power of n kind of behaves in a derivative, the power rule. You bring the n down to the front, and you just keep natural log of a. If you want to put a multiplication sign at the beginning, go for it. So if, let's say for c, when we multiply inside with the natural log, we separate it by a plus sign. What do we do when they're divided? You subtract. Does that kind of sound like the derivative of a quotient rule?
Yeah.
Maybe they're related. Not sure. The next one, what about natural log of e to the power of n? Let's write the understood. Natural log of understood e of the e to the power of n. What do y'all remember about little e and the big E? They cancel, so we have n. So if you don't remember any of this, I want you to try to review them as much as you can. So using them to expand and condense. So here I go. And I'm going to actually do this in a way of one go. If I lose you, most likely you were a little bit confused last year maybe. So here we go. Everyone look up. How many components of E do I have on my denominator on part G? Oh, that's an E. I meant X. 2 of them. So that means when something's on the denominator, we are going to use subtraction. So I'm going to use a combination of D, a combination of C, and E all at the same time. So here we go. When I expand, we get 5 of the natural log of the inside. And that was just on the top. The bottom piece, minus, because it's on the bottom, of the natural log of the x. You can always put that in parentheses. And then I see something else on the bottom, minus. And the way I see the square root is the whole chunk to the 1/2. So I need to go ahead and bring that to the front. Oh, I forgot the natural log. Oops. Maybe I could have made the natural log with that curve. Was not sure. So we have x squared plus 1. So that's how we expanded last year. Let's see how we would actually go about condensing. When I am condensing, how many things are going to end up in my denominator? 2 of them. Anything that's got a minus sign in front is going to go on the bottom. So let's go ahead and write natural log once and give me a long parentheses. So everything with the positive is going to go on top. Everything with the negative is going to go on the bottom. So K has a positive. Put that on top. How about the X? Is it a positive or negative? It is positive, and specifically 3 has to come up to the power. So I'm going to write x cubed. And then we have the Y is going to go on the bottom with y squared because I need to bring the coefficient up to the power. What about the Z? Z to the 4. All right, time for your card on card number 3. We're going to actually add 2 more things sometime this week. So if you would, try to use just the top half. So let's find the derivative of natural log of u. And I'm going to highlight, I think I want to use this, the u. I hope everyone's writing. So natural log of u states the following when we are finding the derivative. All you do is 1 over u, and it becomes a chain rule, then derivative of the u. So if you would, go ahead and circle the u as well. And we'll write the one with the exponential in a little bit, but let's follow this method. If I were to follow this method, and with the same color, where u is substituted, go ahead and circle it with whatever color you want. And that's a calculated portion. Good luck. So let's go and mimic what's going to happen. What I have on the derivative, I need to put 1 over the argument, which is in the inside, times, and then it says to find the derivative of the inside, as in the u. What is the derivative of x squared plus 3? 2x. And this will be perfectly fine for a free response. But if I were to put this in a multiple choice, the better answer I want is, assume that is over 1. So put it side by side, because when you multiply by 1, it is itself. And that will be the best answer if it is multiple choice. So on my test, you may leave it just like that. If I give you a multiple choice, it'll be simplified in this form. Okay? All right. Let's move on to number 2. How many places do I have our variable x? So let's rewrite this. Another way to rewrite this would be x with the parentheses, natural log of x. So what rule are we using from unit 2? The earlier unit 2? Product rule. So let's kind of recap. And I was surprised how very few of us were like, I don't know product rule. So here I go. What is the derivative of my first, everybody? 1. And then I keep. Plus. I keep the first one. And I'm going to go back to my card. My card said derivative of natural log of u is 1 over u. So in this case, derivative of natural log of x is 1 over what? X. And when I derive the inside x, isn't that just 1 that I don't need basically? So if I were to go ahead and further simplify this for our multiple choice question, it's going to look like the following. The x's are going to reduce. So it'll be natural log of x plus 1. So on my test, I'm okay with that. If I actually simplify it all the way, I need this.
Why is it plus 1?
They cancel all out. Okay, I'm going to move on to example number 3. What rule do I have on example number 3? Did someone say chain rule? Very good. So we know it's chain rule because it is the whole component cubed. So let's kind of practice our chain rule. The chain rule says bring the exponent down, and I do nothing with the inside at the moment. 1 less of the power, and then we derive the inside. So when I take the derivative of natural log of x, it is simply 1 over what? 1 over x. And I think I'm going to be okay leaving it just like that. All right, for number 4, how else do you think I'm going to write out the square root? So I'm going to write out natural log of x plus 1 to the 1/2. So let's go ahead and find the derivative of this guy, but leave the 1/2 alone because our coefficient is not going to change. 1/2. What is the derivative of the natural log of the component? 1 over that component. And then what is the derivative of that bottom right now? Do I really need it? And if I were to put this in a multiple choice, Taylor, it's going to be the following. Now, you can choose to distribute if you want it, and I'm okay with that perfectly fine. So when y'all get to a question like this, just rewrite it, and then use your natural log rule and bring the exponent to the front, and then derive it, okay? All right, on the back, let's all go to number 5. And it looks like number 5 and 6 is going to be our new information, and we're doing extra practice with implicit differentiation because we all need that practice. So go to your card and let's add on to it. Now let's write out the derivative of e to the power of u. And again, as a good habit, I want you to circle that exponent. Oh, where's my color? Here it is. And the derivative of e to the power of that component is that in itself, and then our chain rule. And our chain rule is going to apply the derivative of the power. So we haven't done one like this. If it's a little confusing, it's okay. So here I go. Let's go ahead and circle our exponent on number 5. And yeah, let's go ahead and circle it. So let's mimic our rule. Our rule says y prime is equal to the same thing. So copy the same thing. And then derive just the power. When I derive the power, what is it? 3.
That's it?
And that's it. And then the way you'll see this in a multiple choice would be the norm is having a coefficient in the front, and then the exponent, even though e is not the exponent. So the e is really easy. All right, for number 6, before we circle this piece, I want to rewrite all that with without a quotient. So let's rewrite this. I see e to the power of negative 7x to the negative half. Just so that I can make it easier and not use product or quotient rule in the end. So here we go. Let's start by circling. The derivative of e is basically the original. Just copy exactly as you see. And then we derive the exponent. What is the derivative of the exponent?
14.
What is negative 2 times negative 7? 14. X. How many is 1 less than that power?
-3.
And that's it. So really, in the end, I didn't introduce anything brand new, but just those 2 rules, and shouldn't be a problem. So I'm still seeing a lot of you guys that cannot find implicit differentiation, and it's making me very, very sad. So if this pertains to you, or we had the weekend and you forgot, pay super close attention. All right, give me a nod. You know who you are, and I know who you are. Okay, on number 7, let's go ahead and find the derivative with respect to x. And let's see what I have. What is the derivative of x squared?
2x.
2x. Are there any questions on this? All right. And I'm saying this because I was like, oh my goodness, my kid was a little lost. All right. For the next derivative, I'm going to leave the negative 3 alone. But we know the derivative of natural log of y is 1 over what? 1 over y. Now, anything that's changed with a non-x, we need to go ahead and put in dy over dx. If we derived anything with the x, you leave alone. Anything others, you got to put d that letter over dx. The next one, what's the derivative of y squared? 2y. What else do I put after? dy over dx. Equals 0 because derivative of a constant is 0. All right. 2 things that are going to happen concurrently. Listen carefully. I am going to make dy over dx by itself. The first thing is we are going to subtract 2x, and then is there anything else I need to subtract out? Nope.
Would you not subtract the 3?
Well, 3 is stuck with the y, so we're going to go ahead and divide it by negative 3 and divide it by 2y, and also divide it by negative 3y to be exact. So let's go ahead and write out minus 2x. When I'm dividing by this guy, really in the end it's negative 3 over y plus 2y. And let's see what it was asking us to find. That's that. Oh, so this is good if it wasn't a multiple choice. But if it's a multiple choice, here's the first thing that you have to look at. What part of the fraction is messy? Top or the bottom? What about the bottom we don't like?
The -3 over y.
The y specifically. So what we're going to do is multiply by the y on the top and the bottom. The reason is, when I multiply the top by the bottom, this y cancels this y out. Okay, because we don't want too many messy fractions. So here we go. Let's distribute. We get negative 2xy. The next one, when I multiply y divided by y, that's going to remain negative 3. And if you're going, well, I can't see that, then write it out. Negative 3 over y times y over 1. That's going to cancel, so I have negative 3. Write anything on the side if you want. Okay, because at some point, I'm going to stop writing that. Then we have plus 2y squared, and that is our final answer. Number 8 is also a recap. It's a combination from Unit 1. So Colin, go ahead and read number 8, please.
Find the equation of the tangent line to the graph of the equation y equals 3x squared minus natural log x squared when x is equal to 1.
All right, so we want to find the equation of a tangent line. That means I need to find a point. And that point consists of x comma y. We also need our slope. So what do I know about the point that is given so far?
X equals 1.
X equals 1. And then let's go ahead and rewrite this piece. Y is equal to 3x squared. And according to our first page on the first top half, it was minus 2 natural log of x. I'm just rewriting it. Nothing really changed. So now I'm going to plug in the 1. So when I do, I get 3 times 1 all squared plus, minus. So we have minus 2 of the natural log of 1. Isn't natural log of 1 0?
Yes.
So taking a 0 times 2 is not going to help us. So we know the y value is 3. Plug that in. So our point is 1 comma 3. So let's go ahead and write our skeleton model. We have y minus y1 is equal to m times x minus x1 from algebra 1. So we know y minus 3, slope we don't know yet, leave that blank, x minus 1. So our main goal at this point is to find out what is our slope by finding the derivative. So let's write out y prime. What is the derivative of x squared or 3x squared? 6x. And I'm going to actually go down here for the next one. I should have kept it down here. You keep the minus 2. Derivative of natural log is what? 1 over?
X.
1 over x, and that's it. Because derivative of x is simply 1, that I'm not going to write. So then when I plug in the x, we get 6 times 1 minus 1 over 1, which is going to give us 6 minus 2. So how many is my slope function at that point? 4. And that is our final answer.